Hello, on behalf of Transoft Solutions, I welcome you all to the sixth webinar in the 2019 AutoTURN Tips webinar series. For those of you who don't already know me, I'm Charles Sebastian Chalisheri, and I'm a civil technologist with Transoft Solutions, working in the product management team within the simulation business unit, which takes care of all the AutoTURN family of products. Today, the presentation is all about using IntelliPath for analyzing traffic calming. So this presentation, as you know, shall be approximately 30 minutes long, followed by a short question and answer session. At the end of this presentation, we would like you to complete a 2-minute survey, as we really appreciate learning more about our customers and how you use the software. With that, let's start. So here goes the agenda for today's webinar. I will start the presentation by explaining a bit about what traffic calming is, the need for traffic calming, and how it is done. After which, we'll briefly go over the major traffic calming measures that affect the swept path of a vehicle, and also explain the advantages of using IntelliPath tool in AutoTURN Pro to analyze traffic calming. After that, we'll jump onto our technical demo, and then we'll also talk a little bit about project support services and move on to the question and answer session to conclude the presentation. By the way, feel free to ask questions throughout the presentation. So what is traffic calming? Traffic calming is the use of physical solutions like design changes or implementing physical barriers and other measures to reduce traffic speed or cut through traffic with the goal of making streets safer and more accessible for motorists, cyclists, and pedestrians. Traffic calming has been proven as an effective way to reduce speeding on residential streets, and it has been found to avoid traffic collisions and also prevent needless fatalities due to these collisions. Traffic calming in general aims to encourage safer and more responsible driving, helps to improve the comfort level of the passenger, and also potentially reduces traffic flow and accidents. So in short, traffic calming helps eliminate the negative effects of motor vehicles on the road and improves the condition for non-motorized street users. So what's the need for traffic calming? So the traffic calming techniques has been successfully used for decades in cities across Europe. And more recently, in response to the growing number of traffic accidents and speeding issues, cities across North America have begun adopting traffic calming programs to improve the safety and livability on the streets. Studies have shown that traffic calming can reduce vehicle speed and volumes considerably. So some regions found a drop of more than 10 to 16% in the total traffic volume and found that more vehicles were traveling at a speed which is less than 23 miles per hour after implementation of these traffic calming measures in the United States. The accident levels were found to drop by 40%, and also the fatalities due to these collisions were reduced by 33%. Over the past 10 years, pedestrian fatalities in Germany have fallen from 6.2 per 100,000 of population to 2.3. So this effect has been largely due to the lower vehicle speed in urban areas, which was due to the heavy investment done on traffic calming programs. An overall reduction in the personal injury by 41% and reduction in fatalities by 57% was achieved in Berlin. A review of 600 different traffic calming schemes in Denmark indicated that there has been a reduction of 43% casualties compared with the untreated areas. Many studies have also found that traffic calming greatly reduced air and noise pollution in the treated areas, as well as improved the street aesthetics and positively impacted the property value. So now, how is traffic calming implemented? The traffic engineers or public work officials or the urban planners have many strategies for implementing traffic calming programs, which is based on the region and the requirement. These solutions are collectively used to create a more complete streets that offer safe access to all users. So the principal techniques of traffic calming used fall into four main criteria or areas, which are the vertical deflection, visual displays, horizontal deflections, and lane narrowing techniques. So the vertical deflections include speed humps, speed cushions, speed tables, rumble strips, etc. And the visual displays are speed displays or any other message display signs that's on the roadside. So both of these techniques do not have a direct impact on the swept path of the vehicle. So the traffic calming measures that have direct impact on the swept path of the vehicle are horizontal deflections and the lane narrowings. So the most commonly used horizontal deflection methods are chicanes, curb extensions, bulb chokers, pedestrian refuge islands, and traffic circles. So these methods deliberately make the vehicle slow down or alter its normal path, which creates higher driver attentiveness and safe environment. So the lane narrowing techniques helps slow down vehicle by reducing the space available for travel. So the most common methods used are widened footways, dedicated bike lanes, adjacent parking bays, bus lanes, and use of markings and bollards. So what is IntelliPath and how does it help to analyze traffic calming? So IntelliPath tool in AutoTURN Pro, as you know, is an automated swept path analysis tool which analyzes the roads and various constraints within the roads and then automatically creates the simulation while keeping a check on the vehicle limits and making sure that none of the parameters are exceeded. So this tool can generate and evaluate all possible vehicle paths through a route in seconds. It also helps you evaluate multiple vehicles within the same route and also calculate the maximum achievable speed for the vehicle for a particular movement. So all of these mentioned functionality of the IntelliPath tool can be particularly useful for evaluating the effectiveness of traffic calming program and also examining the potential impact of traffic calming measures that's implemented. It also helps to measure the incremental or the bundling effect of the multiple traffic calming devices used together. And also with this tool, many different possibilities or combinations can be tested easily. Multiple vehicle behaviors can be reviewed quickly in very less time. And all these factors collectively contribute to save time and effort and in turn increases our productivity. So with that, let's jump on to our technical demonstration to see and understand the mentioned points better. So before that, for a general overview, working with IntelliPath tool is very easy and straightforward. There are 3 or 4 main steps in the analysis. So the first step is to select an area, like an analysis area, which we have to do the analysis on, and all the exclusion zones, the vehicle roads, and the vehicles are contained within this area. Then we shall select the exclusion zones and lines, which are also known as non-drivable zones or the boundaries which the vehicle cannot pass through. Then the third step is to select the desired route for the vehicle path. Finally, picking the desired start and end positions of the vehicle within the route will let the software create the simulation automatically. So for the purpose of this demo, let's evaluate a typical downtown scenario where traffic calming measures like chicanes and curb extensions are the most popular ones. So these measures aim at reducing the traffic volume and speed within the city routes without impacting the emergency vehicle response times. So for this, let's analyze the main vehicles that's entering the city area, which are obviously passenger cars and city buses and an occasional emergency vehicle access. So let's have a check at the fire truck. So before using the IntelliPath tool, let's see the section we have to analyze is section A, where we will perform some traffic calming measures, and the routes which we will analyze is from X to Z and Y to Z, which passes through A. Consider a situation where there is no IntelliPath and we have to analyze a traffic calming technique, let's say chicanes. So you can see this is a typical situation and we have to check this particular movement, which is XZ, or the route for a bus or a city bus. Let's see how to do it with the ArcPath tool, just a conventional tool, and let's go to vehicle. To select the relevant vehicle, let's go to the AASHTO 2018, which is the latest library from AASHTO, and let's select the city bus, click OK. And now going to the 2D ArcPath tool, you can place the vehicle, orient it, move the vehicle forward, and stop the vehicle. And we have to take care that the vehicle does not go over does not touch the boundaries. And you can take it forward, and then you have to take good care to make the bus travel within or through the chicanes without affecting any of the boundaries. So this might take a bit long, and you know how tedious this process is if we have to analyze this route for different vehicles. So I'll explain how it can be done easily with IntelliPath. So for that, I'm going back a moment and I'm turning this off. And now let's analyze this straight route. So how does IntelliPath work? First of all, let's open the IntelliPath tool, and you can see that, as I explained earlier, there is a pick route analysis area tool, pick exclusion zones tool, and there is exclusion lines, and there is lane lines, and then add a route. So let's select the area. So with the pick, the software recognizes this closed polyline, which I already created within the area, as the analysis area. So this can be a polyline. The software can detect a polyline, line, or a closed polyline, but it was always better and easier and faster for the software to detect a closed polyline. Hence, I created this scenario to make it easier for the software to detect. So I have done. So after we have selected our analysis area, let's select the exclusion zones, which is, again, I have created some closed polylines and which are non-drivable zones, which are buildings and curbs. So I just go on picking these closed polylines, and the software recognizes it as non-drivable zones. So what we basically does with IntelliPath is we set up analysis area for the software to recognize, or some constraints for the software, such that the software creates a simulation which does not excuse me. Yeah, so select the area. Yeah, so we are creating a scenario that is the software uh, does not exceed those parameters within. And our scenario is almost ready. So right click to end the tool, and if there is some exclusion lines or any boundary lines which a vehicle should not pass over, let's select the exclusion lines. And in this case, there is a two-way road and there's a solid barrier in between, so I want the vehicle to pass over those ones. And right click, and this tool is for lane lines. So in this typical situation, this is a one-way road with two lanes. So if we select these as the lane lines, and so the software automatically detects and recognizes that a vehicle has to be oriented along these lane lines always. I'll show you how this works. So right click to end the tool. So first, before we start, I will show you how lane lines work. So let's select, okay, so next let's add a route. So let's say from X towards Z. So let's stop it here for now. And now let's add a movement. So which I'm using a passenger car from the Ashton 2018 library again to explain the lane lines. So where is the passenger car? So here you go. So pick the passenger car, and now 6 miles per hour can be 5 miles per hour, and then click OK. You can give any lower speed you want to test the vehicle. So let's have the vehicle start from here, and now you can see a flag structure. So these are the waypoints which, if you want the vehicles to pass through these particular points, you can pick it in between the road. So now I want the vehicle to travel to the right lane first, or to merge to the right lane in order to have a smooth right turn. So I'm picking it here where the driver would be anticipating to turn to the next lane, and then I can go here and click at the endpoint and right click to end the tool. You can automatically see that the software has created a simulation, and let's see how it is here. So here you can see that. So I'm just turning it off. So here you can see that the vehicle merges onto the other lane. The parameters are not exceeded. Take a right turn here, and then satisfied or solves the path. So this is how typically lane lines work. So let's switch off. Sorry. Okay, and then let's add another movement, which can be a city bus, and then we'll add a fire truck. So let's select the city bus, click OK, same thing, 605 miles per hour, any lower speeds, and let's place it here. So this is the movement which we did previously, obviously without the chicane, and let's click an endpoint here, and the bus travels. So this all happens within a second, and then we don't have to worry about the bus overlapping or going over these exclusion zones or lines, because it won't. So it oversteers here a little bit and then does the turn. So all these are done by the software, and we don't have to worry too much about it. So let's see one more movement with the fire truck. So I think we have a fire truck in our NCHRP report 659 library, and let's select the biggest aerial fire truck. Yes. So let's click OK. Same thing. Speed, I'm controlling it to 5 miles per hour. Click OK. And once again, selecting and orienting the vehicle and clicking to end the tool. The vehicle's here. So now let's analyze another route. So in this particular one scenario, if we do all these setups, we can add multiple different routes and multiple different vehicles within a route. So let's add another route. And let's say that the vehicle is traveling from here to here to here. That's Y from Z. And again, let's try adding movements. So I'm just turning this off for now. And then I'm adding movement. Let's say, let's use the same fire truck for 5 miles per hour and click OK. And click and orient to the opposite side and click and end. The vehicle does the movement. And let's add the city bus once again. So let's go back to the AutoTURN library and select the city bus. Click OK. And click OK. So if only because we had to analyze these different vehicles for different routes, I created all these different vehicles under each route. But in case, if you have to test, like if you already tested the city bus and then you're no longer interested in the city bus, but you have to check the same route with an AutoTURN passenger car or any other vehicle, let's see how we can do it. So just double click the already created simulation. Then it opens a window. Just go here to select the vehicle, and then you can change the vehicle to a passenger car. Click OK, and when we click OK, you can see that the simulation is automatically updated to the one for a passenger car. So that's how easy it is. So let's turn off these simulations for a second, and let's go back. Now let's perform the traffic calming technique, and let's do the chicane. So you can see here that the chicanes are again a closed polyline, so you have to do a bit of rearrangement with the IntelliPath tool in order for it to recognize. So and this tool is to delete anything that we have selected. So clicking this and deleting this selection and this selection, and then right click, takes back to the window. And now I'm picking a new exclusion zone, which is the chicanes. So you can see how simple it is to interchange for both the scenarios. Now let's see the path of the vehicles. So when we turn this on, you can see that the AutoTURN software and the IntelliPath tool is intelligent enough to recognize the change in the exclusion zone, and it automatically updates the path accordingly. So we don't have to recreate the path or reload the vehicle again and again. So it automatically updates. So if we can record one scenario, then on the same on the same setup, we can create multiple scenarios. So let's see how a city bus will travel. And yes, it passes through without any problems. And the aerial file truck travels without any issues. So now let's close these and let's try how the passenger car will travel through the second route. Here you can see that there is no issues and it travels fine. And let's see what an aerial fire truck will do. So it is calculating in the background multiple options whether it will pass through or not, and it finally came up as failed because maybe due to the turning radius or the speed of the vehicle or the width of the lane, it is not feasible for a fire truck or this particular fire truck to pass through this. So we know, or we came to know that the chicanes at this position or this section is not feasible for this particular vehicle to pass through. So let's try another vehicle and see HRP report. There is another fire truck, which is a pumper fire truck, and let's see which is smaller. So let's see if it can pass through. So I'm just clicking OK. AutoTURN automatically updates the path and the vehicle and the parameters, and no. So once again, it's a fail and the vehicle cannot pass through. So AutoTURN recognizes it and stops the movement where it fails any of these parameters. So turning this off once again, and now I'm removing these chicanes. Now let's try some curb extension traffic calming technique in the same section. So I'm adding this as an exclusion zone here. And right click and close. Now I'm going back to turn this layer off and turn this layer on. So now you can see this is a curb extension, and let's see how this vehicle works. So going back to IntelliPath tool, select this the curb extension as an exclusion zone and right click and updating the paths. So we are concerned with mostly with the fire truck. So let me update the fire truck path, and you can see that it passes through without any effort. So let's turn on this fire truck too, and you can see that it goes through well without any difficulties. So this is how you use IntelliPath for traffic calming techniques. You can use multiple variations for the tool. You can perform different routes with many different vehicles, and easily you can perform a big task within no time. So this is how it helps to save time, save our efforts, and also increases the productivity. Thank you for watching. Let's go back into our PowerPoint slides. So as we already know, one of the most important factors in accurate swept path analysis is using the proper vehicle for analysis. So Transoft's project support service team of engineers offers the custom vehicle creation service to help you model unique vehicles which are not currently available within the AutoTURN's vehicle libraries. So for example, if you want to model a specific vehicle from a manufacturer or from a design guideline, our service will create the vehicle for you for a small fee, so that you can perform accurate analysis. If you're interested in availing this service, simply contact our engineers at pss@transoftsolutions.com and provide them the required vehicle information, like the vehicle dimensions, steering characteristics, profile drawing, etc. And based on these given information, we can provide you with a quote and an expected delivery time of the vehicle. So coming back, just quickly, I will show you one more feature of IntelliPath, which I forgot during the demo. And so, in all these maneuvers for testing these, we inputted the speed, which is 5 miles per hour or any other low speeds. But if we want to check, like after this traffic calming technique is adopted, what would be the speed that a bus or a fire truck would travel, let's check that option. So let's double click the already created. So let's double click. It opens. So here IntelliPath allows you to determine the maximum achievable speed in that particular route. So instead of providing a speed, we can have IntelliPath check the speed for us. So let's click OK, and you can see that it takes a little bit longer times because the software in the background has to calculate multiple iterations for the routes and the speed. And let's see what it's going to give. And feel free to provide us with all the suggestions that you feel about IntelliPath or that can make or improve the IntelliPath tool. And we'll be definitely hoping to input those features in our next versions. So you can see here that the fire truck can travel in 15 miles per hour maximum, considering the routes, these traffic calming techniques that's adopted, and this particular vehicle. So this is how IntelliPath helps you do traffic calming analysis. It is also very helpful to use IntelliPath for the site circulation analysis, which I've already done a demo a couple months ago. Please feel free to go back to our website to see the pre-recorded version of those. Thank you. With that, let's jump back. So yes, and you already know the AT Tips webinar, the AutoTURN Tips webinar are held the 3rd of each month, but we'll be skipping it for the next month because we have some conferences that I had attend. And on June 20th, we have a webinar from Parcad, which is based on designing of parking stalls, which makes it easier and saves you time. And then there's on June 27th, there's a guide sign plus webinar, which helps you design guide signs. So come back, and our global technical support is support at transoftsolutions.com. Feel free to get in touch with us with any questions or inquiries, or if you find any difficulties while working with the software. And our sales in North America and Canada, as you can see, sales at transoftsolutions.com. And for Asia Pacific, it's sales@transoftsolutions.com. So with that, we have come to the end of today's session. Thank you very much for attending this presentation. And now I'd like to open the floor to you all. And feel free to ask any questions you have about any features in AutoTURN or Pro. I'd be happy to answer any questions you may have now to the best of my knowledge. Thank you.